Now we're going to talk about a special feature of graphs called their X and their Y intercepts. And these are things that can help us graph a function, or that from a graph we might want to find off of the function because they often have special properties. Okay, so an X intercept is a point where you have a value A, like that'll be some number, and then 0. And on a graph, this is a point where the graph intersects the x-axis. Okay, to find an x-intercept, you're going to set the equation or the function equal to 0 and solve for x. Okay, and we'll do this with an example in just a minute. Okay, but the important thing to know that this is where the graph of a function intersects the x-axis. And you'll notice the x-axis, every point on there, the y-coordinate is 0. So if we look at a graph, right, here's the x-axis, and if you're on the x-axis, you haven't gone up or down at all, so the y-coordinate would be 0. Okay, now if we're talking about the y-intercept, a y-intercept is a point where you'd have 0 and then a number, we'll call that b. And for a function, you'll only ever have one y-intercept because otherwise you would be failing the vertical line test. So for a function, you can only have one y-intercept. If it's just a relation or another graph that's not a function, you could have more than one. So on a graph, this is a point that intersects, well, let's say where the graph intersects the y-axis. Okay, so it would be some point along the y-axis. And here you haven't gone left or right at all, so that's why the x-coordinate would always be 0. To find the y-intercept, you're really just finding f of 0. So you're going to plug 0 in for x, and then you'll find y. So it'll be 0, comma, f of 0, whatever you get when you plug in 0. Okay, now to make this a little more real, let's do an example. So for both of these, let's do, we'll do our example in red. So our example here, we're going to find the x-intercepts and the y-intercept for the function f of x equals x squared minus 9. Okay, so let me graph that. So we want x squared minus 9. Okay, so we see so for the x-intercept, it's crossing the x-axis here and here. And you can actually do that on the calculator by hitting second calc and doing, these are also called zeros, so you could do 2 for 0. So on the calculator for the x-intercept, you're doing second calc, the trace button, and hitting 2 for 0. Okay, then it's going to ask you, we can only find one of them at a time, so if we're finding this one, it asks you to go to the left of it. So you're going to move that little spider thing until you get to the left. So here's the 0, we want to be to the left of it. And then we hit enter. And then it says right bound, so we move past it. We hit enter, and it asks for a guess, so you could just move it a little closer, hit enter. And it will tell us that right there, where it's crossing one of the zeros, is -3, 0. And the other one, if we went through the same process, we'd go to the left of it, then the right of it, hit enter, would give us 3, 0. Now, the method I told you here, you're going to set f of x, so the equation x squared minus 9 equal to 0. Now to solve this, this is a difference of squares, so we would factor it as x minus 3 times x plus 3 equals 0, and then we would set each of those equal to 0. So x minus 3 equals 0, gives us x equals 3. So that was our x-intercept 3, 0. X plus 3 equals 0 gives us x equals negative 3. So that gives us this x-intercept. Okay, now for our y-intercept. So that's the point down here, and if you count down, that's actually happening at y equals negative 9. So from the graph we can see that that's going to be 0, negative 9. Now, how we could have told here, if we found f of 0, that's just plugging in 0 for x. So that would have been 0 squared minus 9, or negative 9. You can do it on the calculator by again hitting second calc, and we're now going to pick value. And then we want x to be equal to 0. Oops. So we would just hit 0. Sorry, that scrolled up. We'll go back to it in just a second. And we would get that negative 9. Okay, so that is how we found the x and the y-intercepts of a graph.